Okay, so here we are in the middle of an insulation lecture, and I'm telling you how evil insulation is and how bad it is for your house. Okay, like I said before, we can never go back to building a house the way we used to build a house 100 years ago. Okay, for the biggest reason I guess is it's illegal. It would never meet the energy code. Okay, we have to have insulation in the house. We have to have a certain amount of water protection and air protection and stuff like that. But the other thing is, we don't have access to those materials anymore. We can't go buy old growth redwood at the lumberyard and build a house out of it anymore. Okay. The other thing is, no one would want to buy that house. Okay. It would be horribly uncomfortable. It's just not really an option. Okay. If we do everything correctly, okay, if we air seal properly, if we understand how vapor retarders and vapor barriers work, if we put insulation in the right places and do it effectively, it can be good for the durability of the house. Okay, and it's going to make the house so much more comfortable and enjoyable to live in, and it's going to have vastly reduced energy bills as well. Okay, the way that CR is building a house now, the utility bill should be $0 a month. Okay. Living in an old house, depending on how miserly you are with the heating, it's not uncommon to have an energy bill approaching $500 in the winter. Okay. It's a significant amount of money. Okay. So what we need to do is we need to understand how these materials have changed, how to make them work in the house, and how to make everything work as a system. Okay, and a lot of this is specific to our climate zone. Okay, which we kind of already covered in that earlier lecture, but again, just understanding how these materials are supposed to work with each other, we can have a comfortable, durable house. Okay, we really need to pay attention to all of the details, though. Okay, we need to properly detail our weather resistant barrier. We need to understand what an air barrier is, where it's supposed to go. We need to understand, like I said, how those vapor retarders are supposed to work, whether or not we need a vapor barrier. Okay. So, revisiting a theme that we talked about before, there are 4 control layers on a house in order of importance. Okay. The most important being the water control layer. Okay. The second is the air control layer. The third is the vapor control layer. And the fourth is the thermal control layer. We're going to be talking today about the thermal control layer. And this is the least important one. Okay? If you do all of these things perfectly, okay, if you perfectly control the air, you could, in theory, not even need a thermal control layer. Okay, but that's difficult to near impossible to do. Okay, so suffice it to say, don't bother doing this until you've accomplished these 3. Okay, if there's air leaking all over the insulation, the effectiveness of the insulation is going to be dramatically reduced. Okay, if your insulation is wet, if you have fiberglass bats in the wall and they're wet, the R value is effectively down to like 0. Okay, so this is one of the steps that, not only do you have to do 3 things correctly before you get to this step, but just doing the insulation correctly, we kind of get one chance to do this as well. Okay, it's all going to be covered up behind a bunch of layers, and we're not going to have another chance to come in and fix it later on. Okay, so first thing we got to do, establish our water control layer. Okay, we need to keep water out of the house. We need to detail that weather resistant barrier properly. Lots of reliance on flashings, tapes, various adhesives, but making sure that no liquid water is getting behind this weather resistant barrier, or everything's over with. Okay, properly caulking all of the cladding, sealing up the cladding. Okay, In that siding lecture, I was saying we don't want to rely on the caulking as the water control layer. That is true, okay? But the more water we can prevent from getting to this layer, we're going to dramatically reduce the amount of water that's going to get behind this water control layer, okay? And then this is the thing, this is kind of the golden rule. We're going to do everything possible that we can to keep water from getting behind the cladding, but we're still going to assume that it's going to get behind the cladding, one way or the other. And so we need to provide a way for it to get out, okay? And the best way to do that is with a range screen assembly, okay? Talked enough about this, I think, but we've got a vented strip at the bottom. These bats are providing an airspace and a drainage plane, okay? Air sealing, okay, we're down to this second control layer here. Air sealing can be accomplished with the weather-resistant barrier if you detail it properly, okay? We want to make sure that inside the building, we're also foaming or caulking all of the penetrations, okay? And this is a huge place where air infiltration occurs, okay? Let's say we did a great job sealing up our weather-resistant barrier, okay? It's all taped and flashed and airtight. All of those penetrations on the outside, receptacles, condensation lines, water service, all that kind of stuff, that needs to be sealed up as well, or else we have a bunch of holes in our air barrier, okay? Inside the house, we're going to have plumbing coming up and down. We're going to have wires being drilled through the top plate and the bottom plate. All of those penetrations need to be sealed up as well, because those are points for air infiltration as well, okay? So that, think of that air barrier, you know, extending beyond just the exterior walls, okay? We need an air barrier at the floor, and we need an air barrier at the ceiling as well, so that we're keeping that conditioned air inside the house, all right? And then the vapor retarder or vapor barrier, if you are in a climate zone that calls for that, okay? But in our climate zone, like I said before, we have it pretty easy. We don't have to worry as much about vapor drive, and all we need for a vapor control layer is latex paint on our drywall, and that's good enough, okay? We also have, typically have a craft paper face on our bat insulation, and that is also a class 2 vapor retarder as well,